Okay, so now we're going to do your recap into macromolecules. So there are 4 basic classes of macromolecules. You have your carbohydrates, your proteins, your lipids, and your nucleic acids. We're just going to focus on the first 3, the carbohydrates, proteins, and lipids, because we've already went into DNA and we'll eventually do RNA. Okay, we're not going to focus on those this time. But when we talk about those, there is a key structure that plays a role in how they work. And the structure is right here. It is H2O, or water. So make sure you recognize what water is. Okay, now this first one that I'm looking at here, this is a carbohydrate. So we're going into carbohydrates first. Now, this is only one carbohydrate. So 1 means mono. And then carbohydrates are your sugar. Now, the scientific term for sugar is saccharide. So this is a monosaccharide. Okay, mono means 1, saccharide means sugar. Now, when you look at this, what you can notice is we have oxygens and hydrogens on here, and they will play a role eventually. But what I want you to see is that we have, here, let me use a different color. We have these molecules put together to make your carbohydrate. And if you look at them, they make a ring-like structure. This is called a carbon ring. Now, this is the great thing about our carbohydrates is they are made up of many carbon rings, and those carbon rings contain lots of energy. So carbohydrates, out of carbohydrates, proteins, and lipids, have the most energy because they are composed of carbon rings. So this here, what I've done is I put 2 monosaccharides together. So this is a monosaccharide right here. This is my other monosaccharide. So together they make a disaccharide. Di means 2, saccharide means sugar. So 2 sugars put together. Now the key thing to look here is when I joined them, I had to pull out a water. Okay, it wasn't possible to join them without taking out a water. So this process is called dehydration synthesis. Dehydration synthesis. Dehydration means taking out a water. Synthesis means to put 2 things together. So dehydration synthesis is taking out a water to join 2 things together. So in this example, I've taken out a water to join 2 monosaccharides together to form a disaccharide. Now, if I look at the energy content, this one has 2 carbon rings. So this one means it contains double the energy of a monosaccharide. More carbon rings equals more energy. Okay, here what I've done is I've combined 3 monosaccharides together. So I want you to look here first is these 3 areas. I have pulled out 2 waters to join these 3 monosaccharides together to form a polysaccharide. Poly means more than 2, saccharide means sugar. So more than 2 sugars put together. I could combine 10 of these things together and it would still be a polysaccharide. But when I look, I see 1 carbon ring, 2 carbon rings, and 3 carbon rings, which means that this contains more energy than your mono and your disaccharides. Moving on to the next class, we have carbohydrates, proteins, and lipids. So this right here is a protein. Now, the basic structure of a protein is called an amino acid. So this is what you are looking at for your amino acid. Okay, there are 20 different amino acids in the world, and these 20 different amino acids make up the millions of proteins that are found within your body, okay, or found within any organism. So these 20 amino acids are really important. Now, 20 things make up a million different things. That seems kind of unlikely, but think about your alphabet. We have 26 letters in the English alphabet, but we can combine them into millions of different words just with different lengths and combinations. It's the same thing with the amino acids. Now, if I combine 2 amino acids together here, I'm going to get what's called a dipeptide. Remember, di means 2, and peptide is the bond that's made in between 2 amino acids. That's why it's called a dipeptide. So amino acids are put together by peptide bonds. Now, same thing, we are combining 2 things together. So we are synthesizing, we are combining To do this, I had to pull out a water. So this process is called, hopefully you said dehydration synthesis. We took out a water to combine two things together. Then I put another one together. Okay, so this time I have 3. So this is called a polypeptide. Poly means more than 2. Peptide is the bond right here between them. So this is a polypeptide. So again, I took out water to join them together. So I joined them together through the process of dehydration synthesis. Now, one other thing to point out is that when you look at this here, you don't see any carbon rings. Really, there is just chains of molecules. And so there aren't any rings. Those rings mean that we don't have as much energy as carbohydrates. Now, proteins are still essential and they're still good for you, but they do not require as many, or they do not have as much energy as your carbohydrates do. Okay, so our next class of macromolecules is our lipids. So we've covered carbohydrates, covered proteins, and now we're doing lipids. Now, in carbohydrates and proteins, you started out with a simple thing like a monosaccharide or amino acid, and we combine those together in order to make your polysaccharides, your dipeptides, etc. Well, with lipids, it's not the same way. We have some basic building blocks, but they don't repeat over and over like they do for your monosaccharides and your amino acids. So the first structure we have is called a glycerol. So this, what you're looking at, is a glycerol. Then we can combine the glycerol with 3 fatty acid chains. So if you look here, they are chains of molecules. Okay, and those chains will contain the energy. Now, again, it's not a carbon ring, so carbohydrates still contain the most energy, but your chains, they still have some energy in them. Now, when I go to combine these, if you look here, I'm going to take out a hydrogen, an oxygen, and a hydrogen, H2O, which is a water. So when I combine these together, I'm going to go through, hopefully you said dehydration synthesis. Okay, so when I look here, I see that I've gone through dehydration synthesis. So I've taken out 3 waters to be able to join my glycerol with 3 fatty acid chains. Again, we took out our water, and that water is our, taking out that water is the process of dehydration synthesis. So what I made here, this one is called a triglyceride. Tri meaning we have 3 fatty acid chains, and glycerol, so a triglyceride. Now, we can classify this even further. We can say that this is a saturated triglyceride. Saturated means that we just have 3 straight fatty acid chains. Okay, so hopefully you've realized so far that when I combine things together, so when I go from this to this is dehydration synthesis, where I am taking my glycerol, my 3 fatty acid chains, or whatever I'm dealing with. I take out water, I join them together, and I end up getting 3 waters coming out, and then I have my combined molecule. So when we combine things together and take out water to do so, that is dehydration synthesis. But we haven't mentioned the opposite reaction, and that's where we go from a combined molecule down to the individual pieces. So this process is called hydrolysis. Okay, hydrolysis, when you look at the word, hydro means water. So this time we are adding water. Lysis means to break apart. So we add water to break apart. So we go from our completed molecule, we are going to add the water back in, and we are going to break apart this molecule. That's called hydrolysis. So dehydration synthesis is taking out water to join 2 things together, and hydrolysis is adding water in to break something apart. Now, the example I've shown you here is with a saturated triglyceride, but this also works for your carbohydrates and for your proteins. Same process. You just either take out a water to join 2 things together, or you add a water to break things apart. Okay, so on this one, we said that a triglyceride that has three fatty acid chains that are all straight is called your saturated triglyceride. Well, this one here, you'll notice that this one has a kink in it. This kink is because of this double bond right there. That double bond causes a kink in one of the fatty acid chains. This is called an unsaturated triglyceride. Okay, unsaturated, if the way to remember that is this kink kind of looks like a U. That U means unsaturated. Okay, so your unsaturated triglyceride has the double bond, which causes the kink. It's still a fatty acid chain, so it doesn't have as much energy as a carbohydrate in its carbon rings, but it is a type of lipid. Now, if I were to take multiple, in this case 3 saturated triglycerides and join them together, you'll notice that they're pretty packed together. Okay, especially if you look at these glycerols up here. They make one straight line. Okay, they're pretty packed together. That means that your saturated triglycerides are solid at room temperature. Now, if you compare that to unsaturated triglycerides, so I have 3 unsaturated triglycerides here. If you look at the glycerol, they are more spread out because of these kinks. The kinks are going to push them further apart, and these are the ones that are liquid at room temperature. So your unsaturated are going to be like your oils, your vegetable oil, your canola oil, anything that's liquid at room temperature. Your saturated triglycerides are going to be your solids at room temperature, like your Crisco, and your butter. That's your basis. Remember, you have 3 or 4 basic macromolecules: carbohydrates, proteins, lipids, and nucleic acids. Carbohydrates have the most energy because they have carbon rings. You have monosaccharides, disaccharides, and polysaccharides. Your proteins are made up of amino acids, and when you join them together, you get dipeptides and polypeptides. And then your lipids, you're made up of glycerols and fatty acid chains. And you have unsaturated versus saturated triglycerides. That's your basis for your macromolecules.